welcome to Pepcoding. So in this video we are going to start the next question from our try module, and the question that we have this time is design, add and search words data structure. So what we have to do in this question is we have to implement a data structure. We have to design a data structure which will add some words into that. Okay, I mean on that data structure we can add some words. Okay, those words will be of type string. Okay, so we'll add some string words and we will also search some words from that. Okay, and when we will search it, it will return us a boolean value, that is a true or a false, on the basis of the word present in it or not present on it. Okay, so this is what we have to do. So let us see that on the board. Okay, and there I'll tell you something more about that. Here is an example. Okay, so suppose what we have to do is we have to implement a data structure, right? So let us try to do that. Suppose this is my data structure. Okay, this is my data structure in which I'm gonna do some actions, like I need to add some words and I need to search some words, right? This is what I need to do. So how I can do that, let us see. So first of all how we can do that is, see, we have a word bad, right? So what we will do, we'll simply add this word. Okay, we'll simply add this word BAD. Okay, then we have a word dad, so let us add this word also. Okay, it is asking us to add this, so we will add DAD word. Okay, now we have a word mad. Okay, MAD, mad. Now we have to search for pad. Okay, we have to search for the word pad. So how we can do that? See, what it will do, it will traverse in this words. Okay, into these words in this data structure, the words that are present, it will traverse into this and will check if this word is pad or not. So here it will tell us that there is no word pad present in this data structure. So here it will return us false, right? It will return us a boolean value, that is false. Now it will go and search for bad. So for bad, it will go into this data structure and search for bad. So here it will find that bad is present, so it will return true from here. Okay, so one true and one false is being returned, and after this we have the search.ad. So what is this .ad? It is a really interesting case. .ad. So at the time of adding words, you will be given a string, okay, which will be of characters only from A to Z. Okay, and all will be of lowercase. Okay, but at the time of searching, a dot can also be given to you. Dot could be given to you. So what that dot means is, dot can replace any character. Dot can replace any character. Like, see, you are given to search word .ad, right? You are given to search word .ad. So in this, it will say that in the place of dot, any word, any character will work. Any character will work. So here it will go to this bad first and it will ask, okay, if there is some character present. Yes, there is some character present. It will not match that even, because here we have dot. So we'll simply want that a character should present at first place. Okay, so a character is present at the first place, so it will go and search and check for the second word, that is A. So here dot is matched. Now A will be matched with A. Okay, so A will be, when A will be matched with A, it will say, okay, true. So go to the next word, that is D. Okay, now D will be matched with D, so it is also true. So it will return true, that yes, this kind of word is present in my data structure. So it will return a true from here. Okay, now we have B dot dot. Now we have B dot dot. So what it will do, see, first of all it will search for the first word, that is B, right? So here it got a word, that is B, right? It got a word, that is B. So here we'll write B. Okay, so B is equivalent to B. Now it will move to the next index. Okay, so now it will check if this, now it has dot here, right? Now it will check after this B, is it contain any element? If it is, then no problem, go to the next index and check if those are equal or not. So in the next index also there is a dot, so it will just ask that do you have the next element or not. When it will say yes, I have the next element, it will simply return a true, because dot can replace any element, right? Okay, so it will also return a true because it has b at the first position, and then dot dot has a and d respectively at their places. Okay, in the place of a and d, in the place of dot and dot, we have a and d. Okay, now let us take one more example. And that example will be let us say BADE. Okay, or we can say BAD dot. Okay, BAD dot. So here what we will do, simply will match b with b. Okay, it is correct. Move to the next index, a and a. Okay, correct. Move to the next index, d and d, right? And then after this we have dot, but here we have nothing. So what should we return from here? See, here my string which I need to find is of length 4, but the string that I have matched with, right, the string from which I have matched my string that I need to find is of length 3. So there is a difference of length, right? Both length are different. That means when both length are different, that means both word are different, right? So you cannot return another word in place of another word. So BAD dot could be any word. That could be BADE, or that could be BADL. Okay, that could be anything, but it cannot be BAD, because BAD dot has length 4, but BAD has length 3. So these are two different words. So you have to return false for this one, right? False for this, because all the strings that are present has length 3. Okay, not 4. So what we can do for this? See, for this we simply will return false. Okay, now the question is how we can implement this data structure. So first of all, I am hoping right now that this question statement is clear, right? This question statement is clear. This dot thing is clear, that what we have to do when we have a dot, right? And how we are going to add word and how we are going to search it, we will discuss it in the later part, that is right now. Okay, so now what we are going to do, we are going to look at the approach. Okay, so I hope that the question statement is clear. So I'm moving on to approach. So let us go to the approach. So for this I'll take one more example. So suppose this is our example, and now for this we'll try to make our data structure, and we'll think on the same way. Okay, so suppose in this data structure I'll first of all add some elements. Okay, so let us add that. We have apple in the first, so add apple. Okay, now we have we have to search APPLE. So what we will do, we'll simply check in my data structure if apple is present or not. Yes, apple is present, so simply return true for this. So we'll return true from this. Now search add word APEL. So we'll simply add word APEL. Okay, we have added this word. Now we have to search for the word AP.L. Okay, so this is a string of length 5, right? So first of all, we'll match first characters AP.L. So we'll match first characters, that will return true. We'll move to next. Okay, we have PP in the second index, so now these are also true, right? So we'll move to next. That means we have dot and p. Dot and dot can replace any word, any character, right? So we'll simply move on and we'll check the next one. So it will be true till now. Now it will check NLN. So L and L are also true. So now we'll move to next one. We have dot in the next, and we have E in place of dot, right? So here, from here also we will return true, because dot can replace any word. So this will also return us a true. Okay, it will also return us true. So from here I will return true. Okay, now we have to search for the app. So here we have app, right? We need to search app, and we have app. Now do we return false or true? For this I'm saying we'll return false. Why? Because APPLE is a different word and APP is a different word. So it cannot be compared with half of the word or with some part of the word. Okay, so that is why we'll return false from here, because there is no word ending app. Okay, there is no exact word app, so we'll return false for this. Okay, so now we have to go to the next word, and the next word is addWord app. So we'll simply add a word that will be app. Okay, here we added a word app. Now it is saying search for app. So what we will do, we'll go into this data structure and we'll check if there is some word equal to app. So this word is equals to app, so simply return true for this. Now it is saying search for .pp search for .pp . So it is of length 5, right? So now what we will do, simply we'll check for dot any number, any character can work, right? So this can also work, this can also work, and this can also work. So suppose I'm checking it with this app . Checking with app, right? App, I'm checking it with .pp . Okay, so simply we'll check this one first. So a can replace a dot, right? A can replace a dot because dot can replace any character. So a will be considered as the equivalent to dot. So we'll move on to next indexes, that is p and p. Okay, so when we move to p and p, so p and p will say okay, it is true. So we will move on to this p, and this p. Okay, so now we are here. So it is saying that these are also equal. So we'll move to next. But here we have a dot, but here we don't have anything. So it will say that this is not equal to this. Okay, but right now it will not return us a false because it haven't checked with all the elements. Okay, so now it will check with, suppose now it will check with this one, this apple. Okay, so we'll move on to this and it will check .pp ... with this. Okay, so now in this, what it will do, simply will match first characters, right? So it has dot in the first, so dot can replace any character. So it will move on to next one, that is p and p. It will match p and p, both are equal. Okay, move on to next one. Next is also p and p, so it will move on to next one. So this is p, this is p, so it will move on to next one and will match next one. It has dot, it has l, so dot and l both can be considered as equal. So it can move to next one and it can also move to next one. So now we have e in the end and dot in the end. So dot can also replace e. So here it is also equal, and now both got out of length. Okay, both got out of length. So in this case it will return true because all the element that I have matched has returned true till this point. Okay, so it will end at the end it will return a true because this word is almost similar to this one, right? So dot can replace any word. So on that manner we'll say that this .pp ... is equals to this apple, or this .pp ... is present in my data structure. Okay, so this is what we will do. So we have now, I think this question statement is completely clear that what we are going to do, okay, and what we have to do. So now the question is how we are going to achieve this, how we are going to do it. So let us come to the problem how. Okay, so for knowing that how we are going to do this, so let us first discuss the most basic, or the, I can say, naive approach. Okay, most naive approach that we can apply here. So that could be, suppose I have added this apple, I have added this apel, I have added this word app. Now someone is asking me to find apple. So what I will do, say let us someone is asking me to search app. So what I will do, I will go to this one and will ask him, are you equal to app? It will say no, I am apple, I am not equal to app. So it will reach to this element, pointer will move to this. Now it will ask, are you equal to this app? No, it is not. So pointer will move to next element. Now it will ask this, are you equal to app? Yes, it is equals to app. So from here it will return true, right? From here it will return a true. So it is a kind of linear search, right? It is a kind of linear search. Here we are searching at every element, we are checking, are you equal to the element that is I need to find. Okay, so it will take it will not give us a good time complexity. It will not be a good solution. If we'll say if we'll completely say, then it will not be a good approach, okay, because it is taking a lot of time. It is checking with all the elements. Suppose for example I'm saying search for SAP, okay, search for this SAP. So what it will do, it will go to this apple and will ask, are you equal to SAP? It will say no. Pointer will move to this, right? So now it will ask, are you equal to apple? Are you equal to SAP? So it APEL say no, I'm not equal to SAP. So it will go to this one also, right? So this one will also say that I am not equal to SAP. So this at this time, suppose if we have right now we have only 3 elements, right? But suppose we have something like 10 power 5 or 10 power 6 elements, right? So this SAP will be checked with each and every word, and after that, after being checked with every word, it will return us a true or a false on the basis of the word found or not, okay? So if the word will not be present in it, then at that time it will take the highest time complexity, okay? So that is why I'm saying that this is not a good approach to do. So what could be the next approach? So for the next approach, we can use a map, right? We can use a map. So what we can do with the help of this map, I will say okay, before map I have one more approach that could be of hash code, okay? If you are aware of hash code, on which our hash set is implemented, it is hash code, right? Every number has a unique hash code. So suppose if you will say, okay, I will find the hash code of apple. Suppose I need to find apple, okay? So what I will do, I'll simply find the hash code of it, okay, hash code of apple, and I'll find this hash code in this data structure, right? But suppose you need to find this this ap.l. It is also equivalent to apple, right? But in this case, suppose here the hash code for apple is 211, but for this hash code will be different, right? This hash code will be different because it is a completely different string, right? Our computer don't know that we are considering this the same, because what it will do, it gives us a hash code on the basis of the characters on it, on the basis of string that we have, right? So it has a different hash code, so it will give us a different hash code, and it will not be matched with apple. So in this case it will be failed. The hash code method will be failed in this case, right? Now what could be the approach then? I will say, okay, hash code is not working, so I'll say, okay, you do it with the help of a map. How? With the help of a map. See, make a map of integer, right, and a list, integer and a list, like vector or array list, okay? Make a map of integer and array list. So what you can do, on the integer, save the size of the string. On the integer, save the size of the string, and with respect to that, in the list, save the integers of this number of size, okay, of this size. Save the strings of this size. Like for example I made a map, okay, and I have some let us say some strings like a, b, c, okay, d, e, f, g, and k, l, and let's say apple, let's say apel, let's say app, let's say mnop, okay? These are some strings that are available with to me, and what I will do, I will make a map, and I'll make a map of the size of the string. That is, for one, this is my, suppose this is my map, okay, suppose this is my map. So what I will do, for size 1, I will have a list which will contain all the strings of size 1. That is, it will contain f, it will contain g, right, and any other no. Now for size 2, I will have I will have all the strings of size 2, that is I will have DE, I will have KL, and DE, KL, and anything else? No, that's it, right? So now after that, for length 3, what I will have? I will have ABC, okay, and after that I will have APP, and for the length 4, what I will have? I will have from here, APEL and MNOP, right? For length 5, I will have for length 5 I'll have apple only, right? So suppose if someone is saying me, I have added these words, right, and someone is asking me to find let's say app, to find app. So what I will do, I will find the length of it. Length is 3, okay, string has length 3, and I'll go to this key, that is this size key, that is at 3, okay. I'll reach to 3, and at 3 I'll get the access of this list, right? I'll get the access of this list. So in this list I'll have some strings. So in these strings I'll check if there is some string which is equals to the string that I need to find, that is there is some string available, that is app, okay. So if in these two strings some string is equal to app, then at that time I will return true, otherwise I'll return false, because all the strings that are of length 3 are present here, right? And it will also handle the dot cases, right? Like suppose I need to find dot pp, right? So what it will do, it is of length 3, right? It is a string of length 3, so it will go to this 3, right, this t3, and will access the, and will check on the list that is present on 3, that for the first index any character will work, and second should be p. So say it will ask, okay, first is a here, right? So okay, it will work, get me the second one. So for b and p it will check, so it will say no, it is not, so it will go to next one. So it will check here again, dot and dot, again dot and dot, that means these are true till this, okay. So it will go to next one. So next is pp, so pp will return true. So not will return true, but pp will say okay, it is correct till now. So it will go to next index. Now it has again pp. So when we'll have again pp, it will again say okay, it is also correct, so go to the next one. Now when both will come out of their length, okay, at the same time when both will come out of their length, when the ending point of both will be same, then at that point we'll say okay, this string is present in my map, right? So here it will return true for this dot pp also. And one more thing, it will also give us the correct answer. It is also one of the approach that we can use to solve this question, which will run correctly for this question, right? But we are not going to use this. Why we are not going to use this? Because in the series we are going to learn try, okay, we are going to learn try, but I have told I told you this approach so that you can know that there is one more approach that is possible to solve this problem, right? And let us discuss that. Okay, what we can discuss? Okay, let us discuss that where it is not helpful and why we are using try over this. Okay, so for this let us go to one more example. So here is one more example. So see, we know that this map, that is the map that we are using, also takes time for rehashing, right? Also take time for rehashing, and rehashing takes time. Rehashing actually takes times. So that is why it could be one of the reason that we are not using this map solution, hash map solution, but using try over it. And but one more thing is, in real life, what problems you will solve, you will not search dot ad or you will not search t.i.d, but in place of this you get to search longest prefix, okay, longest prefix, that is same, okay, longest we can say same we can say, or common, we can say longest common prefix, okay. Or the second example could be lexicographical order, lexicographical order. This could be the second real life examples. So we know that when we use try, and when there is prefixes are same, when there are prefixes are same, then try takes really less time, right? I'm assuming here that you already have solved some question of try, or you have seen the implementation of try before this question, right? So that is why I'm supposing that you know that when prefixes are same, try takes less time, try takes less space, right? So, and next problem, we can that lexicographical order, we cannot traverse into the lexicographical order in this map, right? We cannot go to DE. I mean, we cannot go to this D first. Okay, this D first and and A after that, or A first and D after that. We cannot go to the in this lexicographical order. We need to go to the order which is present on the basis of key, right? So we cannot access this lexicographical order in our hash, in our map, right? In our map or in our hash code solution, anyone, we cannot use this. Okay, so in place of this we are using this try. Okay, now let us see that how try can solve this solution. So as we know that try contains a root, right? Try contains a root. It is much similar to a tree, right? Try contains a root, and this root node contains a child array, right? A child array which will contain some nodes, okay, which will contain some nodes, and the nodes that it will contain, first of all, will make for this one will make the node, and node will contain an array of 26 size, okay, child array of 26 size, which will contains alphabets that are present for this root. Okay, it is the root, okay, and it will be always same. And for this, what we will do, we'll simply make a node, okay, and node will contain a child array that will be of size 26, and that 26 size will tell us that which alphabet it contains, okay, which alphabet it contains. So on the place of that, it has a node, okay, and otherwise it will contain null, okay, otherwise it will contain null. So and what it will contain, yeah, it will also contain a is end, a boolean is end, right, which will tell that where this string is ending, right? This will tell us, this is end will tell us that where the string is ending, okay. So this is what it will contain. So now let us try to implement this, okay, let us try to implement this with the help of try. So now this is the root, suppose, okay. So now I need, first of all, okay, this plus sign shows that I need to add it, and when there is no sign, then that means I need to find it, okay. So now I need to add car. So it will contain an array list of size 26, right, which will contain null in the beginning for everything. For all the 26 element, it will contain null. So now for this, I will ask, okay, do you have C present? Do you have C as the first character is C? So I need to add the CAR, right? So I'll go by character, and I'll try to add the CAR to this root, okay. So now I'll ask this, do you have the C? It will say no, I don't have. So it will make a new node and will add C, and here it will add, first of all, what it will do, it will simply go to this C index and will add C node, okay, which will make C as the child of this root, right, which will make C as the child of this root. So here we have C as the child of this root, and C is added here, and C will also contain a vector or array, we can say, okay. C will also contain a vector, I mean array, okay. C will have an array, and that array will be of size 26, and that 26 will contain null initially because it does not have any child right now, but when it will have the child, it will make a node in place of that child, right? A node will be there in place of that child. So this is how we will do it. So let us try to do the dry run for the same, okay. So I'll not make this this array every time, but in place of this, I will show you that how it will add. So now we added C, right? So it will ask it, do you have A? So it will say no, so it will add A. Okay, and in this A it will ask, do you have R? No, it doesn't have R, so it will add R also. And when it will add R, it will make a boolean true here, right? That it is ending here, is end will be true here. Now we need to add this TRIE. So how we can do that? So for this, what we will do, we'll simply go to this root and we'll ask, do you have T? It will say no. So we'll add this T as a child of it. Okay, this T is added. Now this, from this T will ask, do you have R? It does not have R, so it will add R here. Now from this R it will ask, do you have I? No, it does not, so it will add I here. And same for E, it will add a E here by asking, do you have E? As it does not have E, it will ask E, and it will also mark this as boolean true, right? Because E try is ending at this point, so it will also mark that it is ending here. So this will be marked as true. Now we have to add CARD card, right? So it will go to root. It will go to root first. Current pointer is here. So now it will ask it this root that, do you have C? It will say yes, I have C. So it will move it to C. So we move to C. Now at C it will ask, do you have A? Yes, it will say yes, so it will move to A. Now at A it will ask, do you have R? It will say yes, I have R, so I move to this R. At this R it will ask, do you have D? It will say no. But here, as three words are common, so it will simply add a D. Will add the ending is end here. It will mark it true, and after that simply go back. Right, we have added a word. We are done with adding a word. Now we need to search some C.P, right? We need to sum some C.P. So for this, what we will do, we'll simply ask our root, do you have C? So it will say yes, I have C. So we will reach to this C, and this and from the C I'll ask, do you have any child? Because we have dot, so any child can work. Okay, we can make a call for any child here when we'll have dot, right? So now we'll reach to this A. Okay, we'll reach to this A because we need to find C.P, right? So we'll reach to this A, and with this A we'll ask, okay, next should be P. So do you have P? So it will say no, I don't have P, I have R. So from here it will return a false. So this will return a false, right? This will return a false. So now this is also ended, and we reach to this adding this cards. Okay, so for adding this cards, we'll again reach to this current, right? Current will reach again to this, and from this it will ask, do you have C? Yes, it has C, so it will reach to this one, right? C. Now it will ask C, do you have A? So it will reach to A. As it have A, so it will reach to A. Now it will ask A, do you have R? So it has R, so it will reach to R. Now it will ask R that, do you have D? Yes, it has D, so it will go to D. So when you will come to D, then at that time what you will do, you will ask D, do you have S? It will say no. So when it will say, you will simply add S here, right? And will also mark this true as it is ending here. You will mark it true. Now let us go back. Current will go back to this root, right? Now what we should do, we have to find COR. No, we have to add COT. So what we'll do, we'll simply go to this root, right? And with this root we'll ask, do you have C? It will say yes, I have C. So it will go to the C. Okay, and after coming to the C, it will ask, do you have O? So it will say no, so it will add a O here. It will add O here, right? O will be added. Now after adding O, it will ask, oh, do you have T? So it will say no, so simply it will add T and will make a boolean is and true here, right? So it will be marked true here, and after that we have to add COTS, right? We have to add, we have to find COR first. So what we'll do, we'll simply come to this root and we'll ask, do you have C? Yes, it will say yes, C. So the current will move to this. Now it will ask, do you have O? So current will move to this O. Now it will ask, do you have R? So O will say, no, I don't have R, I have T. So from here it will return false. So this will also return as a false, right? So simply now we have next statement to add something, right? We have next statement to add COTS. So what we'll do, simply we'll go to root, and at root we'll ask, do you have C? So it will say, yes, I have C. So we'll come to this C, okay, and at this C it will ask, do you have O? Yes, we'll come to this O, and at this O it will ask, do you have S? I mean, do you have T? So it will say, yes, we have T. So we'll come to this T, and at this T it will ask, do you have S? So it will say no. So it will simply add S, and will do the is and true here, right? Is and true here. Now let's move back to this root, right? And this time let us find COT dot, right? We are done with adding COTS, so we'll find now COT dot. So for finding COT dot, what we'll do, we'll ask root, do you have C? It will say, yes, I have C. So we'll go to C, okay. Now we'll check, do you have O? So it said, yes, I have O. So it will move to O. Now at O it will ask, do you have T? Yes, it has T. So it will go to T. Now at T it will ask, do you have any child? Because I have a dot. So it will say, yes, I have a child. So it will simply go to this and will return true, as it is also ending, as a word is also ending here. Suppose this word will not be ending here, so at that point we should return false, because at this point this is not a word, right? This is not a word, because this word is not ending here, right? So if I need to find something and I'm finding in this way, then I should return only when I found all the true. That means I found all the characters or dots respectively, okay. And also one more thing, the last character that I'm finding should be an ending character, right? Should be an ending character. So in these cases I can return a true when I'm finding a word, right? So at this point we will return a true. So now let us move on to this T dot I dot D dot. So at this point what it will do, it will simply ask that, is this root, that do you have T? So it will say, yes, I have T. So it will reach to this T. So when I will reach to this T, it will ask this T, do you have any child? So it will say, yes, I have a child, that is R. So it will go to this R. Now at this R it will say, do you have I to the next of it? Do you have a child I? So it will say, yes, I have a child I. So I will move to this. I mean this current will move to the I. And after I it will say, do you have D? So it does not have D as a child, right? I does not have D as the child. So from here it will return false. From here it will check if it is equals to D. No, it is not. So from here it will return a false. So simply will return a false for this one also, right? False for this thing also. So simply false. Now after that we have to add this TRIES. So what we can do for this? So for this, what we'll do, simply we'll go to this root, okay. We'll ask, do you have T? It will say, yes, I have T. So we'll move to this T. After that we'll ask, do you have R? It will say, yes. We'll move to this R. After this we'll ask, do you have I? Yes, it has. So we'll move to I. After this we'll move to E, as it has E. Now at E we'll ask, do you have one more E? It will say no. So what I will do, I will simply add a E here, as I need to add a word, right? So after this E, add one more E, right? And after this E, what you should do, you should simply add a S by asking this, do you have S? It will say no. So simply go to this, add S, and also add the S, make this boolean true, okay. This boolean will be marked true here. After this we need to find this T dot I dot D. So how I can find it? See, it will go to the root, right? First of all, let us erase this. First of all we'll go to the root. So we are at root here. Now at root it will ask, do you have T? So it will say, yes, I have T. So it will go to this. Now when a pointer is at this point, it will say, do you have any of your child? Do you have any child? At T it will ask, do you have any child? Yes, it has. please take me to that child. So it will take it to R. Okay, and after that it needs that I should have one I. So it will ask, do you have I as the child? R will say yes, I have a child I. So it will go to I. Now after going to I, it will ask, do you have any child? Because I have a dot. So it will say yes, I have a child. So it will reach to this. When I reach to this E, it will say, okay, the next child that I want should be D. Do you have D as your child? So it will say no, I have E as my child. So from here you should return false, because the next element that you are finding is not equal to the character that you are, right? So from this point I should return a false, right? So from this I will return a false again. Now here I have I have to add this word try. So for this, what I should do, I should simply add this word try, right? How I will add this? I'll go to this root, right? I'll go to this root, and at this root, what I will do, simply ask, do you have T? It will say yes, I have T. So it will go to the T. Now it will ask, do you have R? Yes, it will say I have R. Go to that R. Now you will ask, do you have Y? It will say no, I don't have Y, I have I. So you will say, okay, you don't have I, but you have TR, so I will give you Y, and I will make this an ending point for me, right? So this is how I'll add one more word, right? See how less space am I using, right? How less space am I using, and I'm making my words, right? I can easily find words in this data structure. I can easily add words in this data structure. So this is why my try data structure is so much efficient, right? Now I have to add this C. So now what I will do, I will ask this root, do you have C? It will say yes. So I'll go to that C, and at this C, I will not ask anything. I'll just mark it is AND true, because this is the only person that is present in my data structure to be added, right? It should be added to my data structure, so it should be the last index of itself, because it has length 1, right? So I'll mark it as is AND true, right? So now suppose somebody is saying okay, find me, let us say find me, let us say C A R dot dot. So what it will do, it will simply go to C, it will simply go to this root and will ask, do you have C? It will say yes, I have C. So it will go to this C, right? Now at this C, it will ask, do you have A? So it will say yes, I have A. So it will go to this A. Now at this A, it will ask, do you have R? It will say yes, I have R. So it will go to this. Now at this point, it will ask, do you have what I will say, do you have any child? Do you have a child? So it will say yes, I have. As I have dot, so do you have any child? So it will say yes. So it will now move to D. Okay, it will now move to D. Now it will say, do you have one more child? Because I have one more dot. So it will say yes, I have. So now it will move to this, right? So at this point, after this point, both strings will be out of length, right? Both string will be out of length, and at the end of this string, it will say, I am also one end. I am also an end, you are also an end. So what I will say true for this, because previous to this, all the characters are same, because this is why you are reaching to me. If at some point there will be a point where these characters will not be matching, so from that point you will go back, you will return false. But when the characters are matching, you will keep on checking till the end, and at the end, when both are at the end, you should return true, because you have traversed the whole string, right? You have traversed the whole string and you have found the whole string. So that is why I'll return true for this one, right? Now suppose I need to find what I should find. I will try to find TRI. I will try to find TRI. right? One example, I'll try to find tri. Okay, so what I will do, I will simply go to this root. I will ask, do you have t? It will say yes. I'll reach to this. Now I'll ask, do you have r? It will say yes, I have r. Now I'll go to this and I'll ask this r, do you have I? So it will say yes, I have I. So I need a t, I need r, I need I. So I found this tri. So I should return true here, right? I should return true here. But will I return true from here? I'll say no, I will not return true from here. Why? Because this, I need to find this tri, right? But this tri should be present in my data structure, not in my try, right? This try is a data, this try is also a data structure which is implementing one more data structure which is capable of adding some word and finding those words with the help of a search command. But no word is ending at this I. Is any word do you find any word ending at this I? I will say no, there is no word ending at this I. So this is why this is wrong. Returning true is wrong. So it should come directly return false from here, because this string is ended, right? This string is also ended, and from here what I have returned, I have returned false, because that was not the point, that was not a point which was a ending point, right? So this is why we are returning a false for that one also, right? So now one more thing is remained to discuss, that is the worst case for this try. The worst case, suppose I need to find this dot 7 times, right? 3 6 8, it is 8 7 times. Okay, I need to find this. So what I will do for this, so simply dot can replace anyone, right? So it will ask root that do you have any child? It will say yes. So it will go to this, current will go to this. Now this will ask, do you have any child? So it will say yes, we are at this, right? So now it will say, do you have any child? So it will say yes. So it will reach to this as I have dot. Now this will say, okay, I have next dot. So do you have any child? So it will say yes. So it will say, I have one more dot. Do you have one more child? It will say yes. Okay. So now it will go to this and will say, I have one more child. Do you have one more child? But here it will say, no, I don't have one more child. That's all. These are the all child that I have. So what it will do now, it will simply return false from here, because it has length 7, but here only we got 6 length string, right? So it will return false from here, and now it will again try to find it has C, right? It has C in this, so it will again try to find this string in the second path. So it will reach to at this point, right? From this point, what it will say, let us go back to this. We are at this point, right? We got a C and we got a C. So from this, what we'll do, we'll simply go to this, and this will go to the next side. Okay, we already have traversed this end, right? So we'll go to this side, and it will say, okay, do you have a next child? So it will go to this. So it will say, do you have a next child? So it will say yes. So it will go to this, and it will say, do you have a next child? Now when it will go to the next child, it will say, I don't have any next child. So at this point, it will say, okay, you are also false, because I have not completed my string dot length. I have not completed my string length, but this string is already been finished, right? This string is already been finished, but my actual string which I need to find is not completely traversed yet. So this is why I need to return false from here also. Okay, so we'll return false from here, and after this we'll go to this root again, right? Let us go back. So we'll return to this root, and we'll ask, do you have one more child? So it will say yes. Now we'll try to find in it. It will say, okay, I have one more dot. Do you have one more child? It will say yes. It will say, I have one more dot. Do you have one more child? It will say yes. And it will say, I have one more dot. Do you have one more child? It will say yes. Now it will say, any child will work. Do you have one more child? Yes. And it will say again, I have a child. Do you have one more child? It will say yes. But here it will say, I have one more child. Do you have one more? It will say no. So at this point of time, it is going to return false, and it will reach to this point, this R, right? It will reach to this point R here, right? So it has visited 1 and then it reached to 2, so it will go to this, okay, and it will say, do I have one more dot, do you have one more child? It will say yes. Okay, we already have traversed this also, so it will say, okay, we traversed to this, do you have one more child, do you have one more child now? It will say no, so it will return false from here also, right? It will return false from here also. So for this case, if you will see correctly, then for this case, isn't it making it like a linear search, because it is going to every node and checking for every string that are you equal to this string or not. So for this multiple dot cases, it will increase the time complexity of searching, right? But if you see the constraints, then these constraints are, you can at most get the length of the string 500, right? So at most the words that you are going to find, at most dots that you can get can be of length 500, right? So that is why this is the case where it can be slow, but otherwise this is completely correct, right? This is running good. We already have considered some real life cases, okay, so where it can run in a good way, okay, so that is why I will say that it is completely a correct way and a good way to implement this data structure with the help of try, right? Now we need to write the code for the same, right? So let us go and write the code for the same, and here I'm hoping that you got this explanation part completely, right? So let us go to write the code. Okay, so let us now have a look into the code of it. Okay, so we were going to code in C++, and okay, so here is the class that we need to complete. Okay, so how we can complete it? So first of all, we need a node, right? Because we are implementing it using try. So for that we need our class node. Okay, a node class, I'll make a node class, and after that what I will do, I'll simply add an array to this, right? I'll simply give this an array, so it will be of type node star childs. Okay, what will be the size of this? So as it is going to it is going to store the children's, right? It is going to store the nodes, and that will be of size 26. That is number of alphabets that a string can have. Okay, so the size will be given 26. Okay, so now, and one more thing, that is bool is end. One more thing is needed, bool is end. So let us make a constructor for this. Childs dot resize, right? And size will be 26. Okay, so 26 is the size now, and so after this we also need a root, right? So we'll make a node star root. Okay, and it will be initialized here, so root is equals to new node. Okay, and after this we need to add some words, right? So for adding some words, we'll simply do node star current is equals to, we'll put a current pointer into our root, and we'll run a loop to add the whole string, right? So for int I is equals to 0 and I is less than word dot size and I plus plus. Okay, so from here I'll add character ch is equals to word at I, right? This is my first character, and after that I got this character now. Okay, my ch variable has the character first character. So how I'll add it? I'll check if my current child's childs child set ch minus a. Okay, is it equals to null ptr? If it is, then something, what we'll do, if it is equals to null pointer, then current childs childs ch minus a. Okay, at this point what we will do, simply go to current child plus a, and there add a new node, right? So we'll add a new node there, and after this current will be moved to current dot childs and ch minus a, right? Current will move to this point, right? If we'll add a node, still we are moving our current to the next pointer. Okay, to the point where we have added a new node. Okay, we'll move our current to that point. Or if that node is already available there, okay, so still we are moving our current to that point, right? And after adding our complete word, what we should do, we should do current dot is and equals to true, right? To tell that here a number is ending, here our string is ending, right? So this is what we will do with our addWord function. So this is it in addWord. Now we are going to search our word. Okay, so for searching our word, what I'll do, I'll simply return I'll write a find function for that. Okay, so I'll find from root, so root dot find dot find what I should find, word, and I'll pass an index 0. Okay, so this is it. This will return me a boolean value, right? So I'll make a boolean function here, bool find, and I'll pass it two variables, that is a string word comma int I. Okay, so for this what I will do, simply if word at if child at, okay, if not child at, first of all we'll check if that word that I'm getting, that is character that I'm getting, word at I, okay, if it is equals to a dot or not. If it is equals to a dot, then for that we are going to do something, right? And if it is not a dot, and if it is a simple character, then for that we were doing something else. So here I have two conditions on me, right? So in the second condition, what I am gonna do, see, if it is not a dot, then what it could be, it could be a null pointer, right? So it could be a null pointer, or it could be a character that I want. Okay, so if my childs of word at I minus a is equals to null ptr. Okay, if it is null, then from there simply return false, because we know that if it doesn't have this character, so how it will contain the whole string, right? So we'll return false from here. Otherwise, see, if child set word at I minus a is not null, that means this contains this character that I want. Okay, if it contains that character that I want, then simply I'll return child's word at I minus a, and I'll ask it, okay, you are there, so find word from index I plus 1. Okay, so simply this is what I will do. Okay, now I'm done with this. Okay, one more thing is remaining, that is what will I do when I'll encounter a dot. So when I'll encounter a dot, at that time I'll give chance to all my nodes, right? So for child colon childs, right, type is node star, or node star child colon child. Here what I will do, simply okay, everywhere it is node star, right? Node star. Okay, so where were you're here? Okay, now so I'll give chance to every child, right? I'll give chance to every node, that if you are not null, I'm giving you to go for the next one, right? I'm saying if you are not null, then you can be my answer, right? So I'll simply check if my child is not equals to null ptr, right? And If it is not equal to null pointer, or it is something, that child is something apart from null, so what I'll do, simply child find, okay, word and I plus 1. Simply this, okay. If this is returning me true, then I will return true for this, okay. Return true for this. Otherwise after coming out of this, I will return false. Simply this is what I'm supposed to do, okay. Now at the end, I also need a base case, right? So when will I hit my base case? I'll hit my base case when I traverse my whole string, right? I traverse my whole string and I have checked if it is present or not. So if I'll reach at my last index, after my last index, that means word dot size, okay. If I reach at my word dot size, that means before this I have visited my whole string, okay. So I have checked each and every character of my string, and after that I am here now, okay. So now when I is equals to word dot size, at that point also I need to check if it is some ending point or not. If it is some ending point, I should return true, otherwise I should return a false, okay. So what I should return, I should say, I can simply return is end. That means if it will be ending there, is end is a boolean, right? So I'm supposed to return a boolean. So if is end is true, it will return a true. If is end is false, then it will return a false, okay. So simply this is what I'm supposed to do. And yeah, this is it, I think, that we need to do. So let us try to give it a run, okay, and check if it is running or not. Okay, it is accepted. Let us try to submit it. Completely accepted. So I hope that you got this question completely, okay. It was an interesting question, and here in this we implemented our data structure by our own, okay, with the help of this try data structure. Now we'll meet in the next video, okay. So till then, goodbye, and also don't forget to like the video and also subscribe to our YouTube channel if you are new here, and you can also share this video with your friends. So till then, goodbye, take care. We'll meet in the next video now. Bye.